أهلا بكم في قناتي سات ماث 800. Today's lesson is about rational expressions and radicals. We will start with simplifying rational expressions. What is rational expressions? It's about a binomial like this or trinomial, and it's about numerator, and it's in the form numerator over denominator. So it is rational expression. To simplify this rational expression, we will factor the expression. X squared minus 9, it's a difference between 2 squared, so it's x minus 3 times x plus 3. We will factor the denominator. It is x minus 3 times x plus 3. We will see that x minus 3 is in the numerator and it's also in the denominator, so we will cancel the two factors with each other. We will have the remain x plus 3 over x plus 2, and this is the simplest form for this expression. We have to say that x is not equal minus 2 because we don't want the denominator to be equal 0 because it's undefined. Second, we will talk about multiplying and dividing rational expression. This is a rational expression times another rational expression. We will factor this x minus 3 times x plus 3, also the denominator x minus 3 times x plus 2, and this expression x minus 3 times x minus 1, and x minus 1 x plus 3. Here we will cancel x minus 3 with x minus 3, and here we will cancel x minus 1 times x minus 1. The remainder here x plus 3, and the remainder here x minus 3 over x plus 2 times x plus 1. And we have to say x is not equal negative 2 and x is not equal negative 1. Now we will talk about radical expressions. What is a radical expression? It's about the root. The radical symbol is the root. It is called radical symbol. The radicand is under root. The number of the which we will put here, it is the index. It can be second or third or any number. For example, a radical expression is include square roots, cube root, or any other roots. For example, this is when we don't find an index here, that indicate that the root is squared root. This is also squared root x plus 5. This is a cubed root x minus 9. Radicals can be simplified by factoring out perfect squares or cubes when possible. For example, if we have root, this is a square root 50, we will simplify 50. We will find 50 is equal 25 times 2. 25 is a perfect square. It's become out of the root as a 5. So this root 50 will be 5 root 2. Radicals are common in SAT problem that's involving geometry, quadratic equation, and function. So we have to study it well. The structure of a radical. There is the same as a radical expression, but there is here the exponent. This is radicand, as we said, radical symbol, index. When we find x have an exponent, so x will be, the exponent of the x is a over b. The index of the root will be in the denominator, and we should say that b is not equal for 0. For example, squared root a, that's equal a to the power half. This is square root. We always don't put 2 here. When we find there is no number here, that indicates that a square root. Cubic root is equal a to the power third. So a root a and the index is n will be n a to the power 1 over n. The operations with radicals. We can add and subtract radicals. When we have the same root, root 2, and this is root 2, we can, it's like x plus 3x. It's like 3 orange plus 4 orange. The root 2 is like a block here. So 3 of this plus 4 of this equals 7 of root 2. So we don't look inside the root. The root here is blocked. 3 apples plus 4 apples equals 7 apples. Only combine like radicals. Multiplication or multiplying, it's more powerful than addition and subtraction. It's go under the symbol and we can multiply the under symbols. So is root 3 times root 12. We will multiply 3 times 12. That will be equal root 36. That gets us 6. Multiplying under the same radical. If this is a square root, of course, and this is a square root, the answer will be square root. We can't add different radicals. It's a cube root. We can't multiply with square root. About division, it's the same. Division or multiplication, we can go to the number under the radical. 20 over 5 equal 4. Square 4 equals 2. Rationalizing the denominator. When a radical appears in the denominator, it's often necessary to rationalize it by multiplying the top and the bottom by suitable radical. When we find the root in the denominator, we can't, this is not the simplest form. So to cancel this radical, we have to multiply both numerator and denominator with the same root. When we multiply the denominator with the same root, so we'll get the under root, the number under root, and we will get the numerator 3 root 5. So this is the simplest form. That if the numerator is, the denominator is one term. We can find also the denominator has 2 terms, binomial. We multiply by the conjugate. What is the conjugate? The conjugate is the same root, the same term, the same binomial, but in different sign. So the conjugate here is root 3 minus root 1. And we have to multiply root 3, the conjugate, in the numerator and the denominator. We get multiplication by these 2 conjugate numbers. We get 2, a number, a normal number without root, and the root will be in the numerator. And that is the simplest form. We will see here the radical forms and rational exponent form. If we have a to the power m under the root to the power n, a will take the power m over n. A equal m over n. Any exponent number, any number have a power under the root, we will divide the exponent over the index. So 4 equals x over 3. Here there is no number, so we know that it is squared root. A to the power 5 over 2. But here we said that a to the power 5, a to the 5 equal a to the power 4 times a. So a to the 4 gets out of the root. It becomes a squared times root a. When you let it inside the root again, it will be a to the 4, and when we multiply, we get a to the x to the 5. Example, simplifying mixed radical expression. We have here 3 root 18 minus 2 root 8 plus root 50. Of course, there are different radicals, so we can't multiply or we can't add or subtract. We will factor 18. It's equal 9 times 2, and 8 is equal 4 times 2. 50 is 25 times 2. Root 9, in the multiplication, we can distribute the root for the two numbers. So root 9 times root 2, that's acceptable. Minus 2, root 4 times root 2, plus root 25 times root 2. Root 9 is this 3. So 3 times root 2, minus 2 root 4 equals 2 times root 2, plus root 25 equals 5 times root 2. We will multiply 3 times 3, it's 9 root 2, minus 4 root 2, plus 5 root 2. Now we can subtract or add the same radicals. 9 minus 4 plus 5 equal 10 root 2. Hope you enjoy watching this video. Don't forget to like and subscribe.